All matter in the universe was created in one major cognitive reaction. This led to massive corpuscular distortion and high levels of proto-theognetronic radiation, causing the manifestation of innumerable dimensional planes, 4 of which contained enough potential inspirational energy to continue to expand as space-time. We can see from this model that the conceiving mind, or God, has access to any point on n or q, with n equaling space and q equaling time. Although the reaction occurs at n 0, 0, where q equals 0, evidence has shown that G cognitrons are present across every instance of n, and an unusually large concentration discovered at n, where q equals 14.995, could imply that the entire universe was conceived at a point W. The first 10 to the power of 2 seconds of the universe are known as the prenucleosynthetic period. In this time, space underwent rapid cooling and thinning from around 19 billion degrees centigrade and a viscosity of 7.894 to conditions similar to its present state. The proto-prenucleosynthetic period was home to a complex ecosystem including leptons, quarks, gluons, hadrons and hadrosaurs, gravitons, electrons and positrons, dimetrodons, neutrinos and cannibalions. Energy was abundant, and particles were able to thrive, grazing on proto-theognetronic radiation and catching photons. Some particles were certainly carnivorous. Evidence shows that hadrons and leptons may have preyed upon photovores such as neutrinos. However, the top predators of the prenucleosynthetic period were the cannibalions and anticannibalions. These formidable particles hunted in swarms, devouring entire species of lesser particles until they eventually annihilated each other. Some groups of neutrinos and gravitons were able to take refuge in neighbouring dimensions, although it is uncertain whether any others were able to do so. By the Juto-prenucleosynthetic period, beginning at around 10 to the power of minus 10 seconds, the temperature was considerably lower and the surviving particles had to adapt. Quarks were the dominant species by this time, most likely due to a post-cannibalionic rise in the number of photons. This allowed them to find enough nutriments to maintain their metabolic frequencies, and with the disappearance of antiquarks, they began to gather into groups of 3. This probably helped them to reduce heat loss. These groups, or herds, evolved into superparticles, more commonly called protons and neutrons. As radiovores, electrons and positrons were able to continue to exist in this environment. However, as levels of radiation dropped, their numbers dwindled, and by the end of the pre-nucleosynthetic period, positrons had all but vanished from space-time. In the first stage of the post-nucleosynthetic period, beginning at around 10 to the power of 2 seconds, protons and neutrons had established the first nuclei, most likely to conserve as much energy as possible in the increasingly hostile environment. Many of the surviving electrons began to graze within the protection of these larger groups, leading to the formation of the first atomic ecosystems, commonly known as hydrogen and helium.